everybody, and today I will be talking about sustainable architecture and why we should care as college students about sustainable architecture. So, in 2019, there were floods in Venice, Italy that caused billions of dollars of property damage. The whole city was basically submerged under 6 feet of water, and which gradually increased over weeks. Not increased, decreased over for weeks. And that flooding is still very much a real part of what Venice faces today. Why, you might ask? It was because of sea level rise, which has been exacerbated by climate change. Scientists have known about climate change since the early 1960s. They started documenting carbon dioxide emissions, and also they've known since the 1880s about phenomenon such as the greenhouse gas effect. Here is a clip of the New York Times in the summer of 1988 that talks about global warming. And so we have been anxiously looking for solutions to this problem for decades now. And the solution I am proposing today is sustainable architecture. So why choose to focus on buildings? First of all, buildings are a fundamental part of our society. The first structures that we built as humans were shelters. Here are some examples of those. And also, the building sector in and of itself is contributing a lot to climate change, specifically through CO2 emissions. So the building sector by itself contributes about 40% of emissions annually. However, this doesn't include the transportation emissions that happen from taking building materials from one place to another, workers, or what the buildings are used for. So I'm going to go ahead and tackle some of the common problems and causes and effects of climate change and how architecture impacts each of those. So I'm going to start with the big one, which is carbon emissions. So most of the CO2 emissions come from production of cement. So this is some data about the emissions that happen during that process. And then also cement releases emissions after it's produced as well. Cement is also one of the biggest materials that we use in both private and public buildings and infrastructure. The architectural solution for that is being presented is the use of engineered wood. Now, if I was asked, is a tree stronger than a block of cement, I would probably answer no. However, this is special wood. It is engineered specifically to be as strong as concrete and replace concrete structurally. So as you can see here, this is a picture of a skyscraper that is being built completely out of this engineered wood. This wood is also coated with fire-resistant materials as part of the engineering process. Another architectural solution to carbon emissions are carbon capture technologies. So the most common application you see of this is the introduction of plant life into architecture, so incorporating vertical gardens, rooftop gardens, because plants are natural capturers of carbon dioxide, so they'll do that naturally. Also, offsetting carbon emissions can happen by tackling another huge emitter of carbon, which is the energy sector. So if you supplement energy production and electricity through use of solar design, then that will help reduce emissions. So this is an example of active solar design, and that just means that it uses active technologies such as solar panels and whatnot to generate the electricity needed for this building. And then here below is passive solar design, where buildings are actually designed and oriented around the sun's path and airflow on the interior to help with to efficiently distribute energy and heat throughout the entire house. Something else that will be impacted and is impacted by climate change is biodiversity and food. And architecture also has a few solutions to this as well. Whoop. Let's go. There we go. Okay. So up here on the screen are just a few of the foods that are being threatened by and are being limited by climate change currently. So these include a whole lot of produce, pretty much anything that lives in the ocean, and your favorite chicken nuggets and fries. Why won't I go down? Okay, there we go. So the proposed solution to this is through the use of zero acreage farming, which is basically incorporating farming into buildings and urban areas. So you have soil farming, which happens through the use of rooftop gardens and farms. And then you also have soil-less farming, which doesn't need soil, obviously, and it can be integrated through the use of vertical gardens, vertical farms, greenhouses, and also shipping container farms on top of buildings. This also doesn't just apply to plant life, but applies to animals. One of the popular uses of these gardens is to actually do both through the use of hydroponics or aquaponics, where you raise fish and plants at the same time, and the plants feed the fish, and the fish food acts, not fish food, fish waste acts as the mineral content and needed for the plants. So something that is also threatened by climate change is the access to water. So I've already mentioned two uses of vertical gardens, both for a food source, carbon capture source. Well, it also can be used to capture water. And then there are other techniques that are inspired by practices that are already being used in third world countries to capture water. This is an example down here of a simple design where water hits the roof and then it runs off into these rain barrels. And then up here is more of a high-tech design where water is collected from the roof and then distributed throughout the building for use. This also, water capture is also important for gathering gray water, which is not safe to drink, but can be used to water plants, can be used in bathrooms, things like that. There are also filtration systems being developed to include in buildings that filter these waters so they can be used for drinking and whatnot. So as I mentioned before, actually I don't know if I mentioned it yet, heat is a huge problem. It's called global warming for a reason, and that is because overall the temperatures are rising, and problems that happen because of that are fires, an increase in fires. So this is a picture of the fires that have happened in the Amazon and the recent California fires here on your right. So the way architecture is combating these problems is through designing houses specifically to resist fire. So a lot of this has to do with overhang and roof design. As you can see here, this is like a bush house that is built into the hillside, and it is the roof or overhang is meant to protect it from fire. And here is a diagram of how that works. Also, materials are important to consider. So things such as straw bale homes that are, the walls are built with straw bales and then they're covered in adobe or some other fire resistant mixture. Those stand up well to fire and are also sustainable because they use local materials rather than shipping in materials. And then also, it might seem counterintuitive, but the engineered wood that I talked about earlier actually passes fire code by quite a bit. Like it lasted 1 hour longer than it needed to pass fire code. So it is safe and fire resistant for use in buildings. So as I mentioned before, sea level rise was part of the problem with Venice. And while I'm not proposing any solutions to deal with historical already built buildings, I will be talking about some architectural solutions to sea level rise. So this is an American coastline in the aftermath of a flood. This is pretty common. If you go to the coast, you'll see a lot of new builds because people are rebuilding their homes every year after hurricane season, which isn't good for the environment or climate change either. Here are some floating houses in Amsterdam. They were built specifically on the water with this sort of modern aesthetic. And then over here is a rendering of a traditional New Orleans home that was built to optionally float when it needs to, because New Orleans is prone to flooding because it is below sea level. And this keeps with the same aesthetic of the neighborhood as well. So the big question, what is the cost of sustainable architecture? So sustainable architecture sustainable homes only cost about 5% more to build than regular homes. Part of this is because of the incentives. So, sorry. So the EPA and the US government provides many funding opportunities for green infrastructure. On this page up here, which I have linked, there are over 50 different funding resources available for the general public to take advantage of when it comes to building green. Also, having green buildings saves you money over time. So it's a small initial investment, and then the savings you get from decreased electricity bills and whatnot actually saves you more money over time. So the sustainable aesthetic, when talking about aesthetics, it is important, sustainability, it is important to talk about aesthetics because it is a fundamental part of the sustainability. As mentioned by researchers in Norway who took a look at different aesthetics around the world, regional peculiarities are undoubtedly relevant to sustainable architecture, including climatic and material aspects, aesthetic expression, and the links with the context of buildings. So up here, these are all examples of top sustainable buildings. Some of them are prettier than others and therefore more likely to be kept around longer, regardless of the sustainable technologies that are in place. Here are some examples of some maybe more traditional looking houses that incorporate sustainable architectural design without losing the character of the region that they're in. As you can see down here in the bottom right, this is actually a clip from a building in a sustainable city in Dubai, and it includes some coloring that is traditional to the area as well as patterns. So sustainable architecture can be used to meet community need. I talked about food, water, electricity, which are all very important, but buildings in and of itself, sustainable buildings, can be used to improve other things such as low-income housing. Sustainable designs tend to be a better design for those and increase the functionality of low income housing. Here is an example up here on the top right is an example of a community building. It was built as a multi-purpose building, so it could change over time as community needs differ, but the sustainability and the green architecture of it remains the same. Down here is a proposed example of a public restroom that is actually sustainable, which is not something that people necessarily think about often, but it is a community need that needs to be met. And then already across the US, we are seeing an increase in hospitals and schools that are moving towards more sustainable designs and upgrading, which is good. So what will happen if we don't change how we build? The first answer is we're going to have to change how we build because of something called urban heat islands in the cities. Because of the concrete and the density of the buildings and the lack of greenery, the temperature in cities is dramatically higher than it is in other areas. And so what will happen is those are becoming less and less livable, and we simply do not have the land to spread out if cities become no longer livable. And then we are also currently straining our natural resources. So water, cropland, things like that, that can be substituted and supported through architecture. If we do not, these will continue to be drained out until we have no other alternative. And then property loss. The top two pictures are pictures from Texas. So the recent flooding and then the recent storms. And then this bottom one is the aftermath from the California fires. So if we do not change our buildings to withstand the increase of these natural disasters, then we won't have houses anymore. We'll keep losing houses and shelters and buildings. So as college students, what can we do? Mainly right now, since we're not looking at purchasing homes, we can support and advocate for green building projects in our areas. This might include helping with fundraising campaigns, calling local politicians, engineers, and getting in touch and raising public awareness. And then also as we start to collect stuff such as electronics, furniture, things we're going to take into our young adult lives, we can start choosing more sustainable and energy efficient options. So thank you for listening, and hopefully this inspired you to seek out sustainable architecture in your future. And on the next slide, I have listed some more sources if you want to do some more research. Whoop, there we go.